Hello. My name's Marc, freelance software engineer from Munich, and I'm going to give a talk in opposition to Mido's talk about class hierarchies. Although it's a small class hierarchy, it's necessary for a problem I had when writing the resource manager of my rendering engine. What I tried to do is a one-to-rule-them-all solution. So I want to support DirectX, Vulkan, and so on. But I don't want to write a resource manager for each of those separately, because usually you have a tight coupling between the graphics API and the resource management. And that annoyed me like hell. So I thought about a very, very abstract core model for resource management and tried to outsource the specifics of the platform to the lowest level possible. What I want to introduce to you today, I wanted to have a task backend because I wanted to have asynchronous and synchronous resource generation and management. And the task backend itself spawns tasks for each of the separate resource types supported in the engine. They all have a common interface for creation, update, deletion. But I didn't want to write everything by hand. I wanted to use the compiler to generate things. That's why we have to deal with several Kenobis. The problem is that we have one common scheme of creation in a non-technical level, but we have to reflect that somehow technically without having a huge amount of code bloat using templates, because I'm a template guy. And so what do I want to have? I want an interface or an abstract class to permit dynamic dispatch. I want to be able to specialize by derivation the specific resource backends that spawn the tasks and hook into a resource task to create the resources on the graphics card. I have a finite set of types. I try to keep it as small as possible. And in addition, I want to have a templated single point of contact. I'm going to go into the details why later on. I want to have type safety. I want to have the compiler to do as much as possible. I want to be dry. I don't want to repeat myself. And I want to follow the solid principles. So what did I do? I don't know what's your level of C++. That's why I repeat what's an interface. Who didn't know what an interface is? That's good. Basically, this is my task creation interface. It just declares one of the functionalities required. It simply says spawn creation task and takes a descriptor for the specific type. It's just a nested struct. And I can just define it, pass it in, and get back a handle, an 8-bit handle to my specific task in the backend. How did I create the abstract task backend? I did it that way, variadic templates. I just define a set of supported types and inherit them. And then I have my single point of contact function, because many of the core models of my resource manager are single point of contact, which means they are templated, so I just want to have one method and do not want to resolve things during runtime again. Now, how do we select the proper override now? Yeah, we have a pure virtual function in our base class, but now we have many of them, so we have ambiguity. Ambiguity. How do we select the proper method based on the template type? Because now we have only the templated resource type. The first option is just calling the function. Now we have the problem. Which of the functions do we use? Because we would need overload resolution. The problem is the template is part of the nested type specifier. So it is not deduced by the template argument deduction mechanism. Consequently, the overload resolution fails. What we get is we cannot find a proper method to call, although we know there is. The second thing is we do a qualified name lookup, specifying the specific template base class to use. But now we have the problem that those qualified name lookups disable the dynamic dispatch and virtual call mechanism. So we completely cancel the purpose. The third way to do it is a compromise. Cast to the specific type that we want to have, and then invoke the virtual call mechanism. That's the solution that will work, and the proper method will be called. This is an example implementation for 3 types. Now we just define a list of types, put it into the variadic template parameter in our example task backend, declare the virtual functions and define them. I just defined one of them, returning 1, 2, and 4. And this is how how it will be used. We have our polymorphism. This is our abstract base class, and now we can spawn whatever graphics API task backend we want. And this is the way we call it. And then we will get the proper tasks being created, and we can just call them or enqueue them somewhere in whichever resource loading mechanism we want. It's over, but I will finish this right now. It's just half a minute. Why not just declare everything in a pure virtual interface on one level? First of all, redundancy. I have to write all the methods for each of the types repeatedly. The second thing is interface segregation. I want to be able to just take part of the resources or one specific resource interface so I can cast it over and pass around the pointer. So I can be very specific, very explicit in some other client parts of the software. And also single lines of code. By abusing the compiler to generate things, we keep the lines of code small because the stuff is generated in the background. And I love templates. Any questions? Thank you.
Something CRTP is solving actually?
I don't like CRTP for several reasons, so I tried to solve it. Huh? Could you please repeat the question? Somebody didn't hear it.
This is not solved by CRTP, by using just CRTP actually, basically. Please, so you repeat the question for the microphone.
Okay. So I'm not so good at following orders. So he asked if this is not a CRTP thing. Yes, I tried to do it that way first of all. But I realized that it implicates a lot of other ugly stuff with binding, accessing things, and the problem with CRTP is I have to pass the specific type over and over and over. And at some point, I don't want to have the backend visible in my core model anymore. That's why I don't use CRTP, so I don't have to specify it on a core level, but can really inject it from the outside. Yeah?
You say you have a finite set of types, so some types? Yeah.
I forgot to say this. I used this for a customer, and he only permitted C++11. And he is not a fan of all that fancy new stuff, so he wanted to restrict to old mechanisms from C++. So if I could, I would not even use that system, I guess. I would go for a variant solution. There are many other ways to solve this. This is quite an ugly thing. And it implicates a lot of things with name lookup, template argument deduction. So I could go even more into detail and fill 50 minutes about just how the compiler tries to select that stuff and why we have to do it in a specific way. I just wanted to highlight that intrication of the name lookups and stuff like this. There are cleaner solutions, definitely. Anything else? Cool. Thank you for listening.